So this Professor Brun, who authored the negative paper on Mile, did us a good service here. These are Maxwell's original equations. If any of you know Tom Bearden's work, he says that Maxwell's equations are inaccessible because there are 22 equations and 22 unknowns, and he used quaternions. And you weren't smart enough to understand what quaternions are. Well, they're just vector calculus, just the origin of it. So our modern vector forms are very economical compared to Maxwell's. And I think had Maxwell lived longer, he certainly would have done the work himself. Just a reminder of divergence. A couple of sites would have the curl. So I got this from University of California, Davis, saying that curl of the E field is created by an increasing B, and the E field lines form a vortex or eddy, just like Miles is saying, the contracting vortex. So the current, J, of Ampere's law is current density, amps per square centimeter, if you like. And Miles' new term is potential density. So it's a fair deal. So there's no strong theoretical reason why magnetic monopoles shouldn't exist. They just don't seem to. We've never seen one. If they do turn out to exist, it's no disaster. All we need to do is add a magnetic charge density to Maxwell's second equation, Faraday, in place of the zero. You could probably do some cool things with it if you could find one. Well, you could do things like this. So this minus V div B that Mile has put forward to balance out Maxwell's equation is there. And that doesn't seem to be very extreme. I don't think there should be a lot of opposition to that proposal, because if it turns out that div B is zero, well, it's just Maxwell as it has existed for a century. So this these equations are from the Scalar Waves book. They're fascinating reading. This book, by the way, it's available from Miles' web store. I don't know that you can buy a hard copy elsewhere. There are PDFs floating around. So we need to enhance Faraday's law, just as Maxwell enhanced Ampere's law. It needs a second causal term on the right. That term is potential density, as opposed to current density. Then Maxwell would be symmetrical. Yes, there would be magnetic monopoles. I almost got another video of to give you a chance to assess Mile. Actually, we didn't bring any members. This is how we should
Here we have. So, this is textbook physics. On the other hand, now we have, in duality, we have this potential density that up to Maxwell had put to zero, and we have discussed this because this could be described as well by a time constant in duality, and this time constant is the time constant of potential vortices. The problem we have is that well, in many textbooks, perhaps in the textbook of Jackson, Classical Electrodynamics, we have the problem that they say the divergence D is producing electrical monopoles, and that means the divergence B should describe magnetical monopoles, and they have searched for them and not found, and then they said it's impossible to find magnetic monopoles, that's why they do not exist. But, and that's why we can put this to zero, you see. Yes, that is the Maxwell approximation I'm always talking about. And that means you can put this to zero. But I have told you that you can only describe perhaps an electron as a vortex if in the inside you have the expanding vortex, and that is described by divergence D, and outside you have the contracting vortex, that's divergence B. That means to describe these charge carriers here on the right side, I need both. I need both. That means that this description you find in the book of Jackson is a mistake. It's nothing than a mistake, a horrible mistake, because he says that this has to put to zero because this would describe magnetic monopoles. That's not right. We get electrical monopoles by both, and we get magnetic monopoles as well if we take both. But the difference is, if I'm in a conducting material, then the magnetic monopoles would be huge, as big as our cosmos, perhaps. If I'm in non-conducting materials, then the size is very, very small, up to atomic dimensions. And then...
So there's the man himself. And I think he's the Black Forest Copernicus. I think he's done a stupendous service to mankind. He certainly deserves a Nobel Prize. Instead, he gets ignored and shunned. Now, how can we remember minus V div B? I mean, we're going to forget that. But we won't know that tomorrow morning, will we? So, who knows the show Cheers, the bar? I mean, Sam Malone was taking a night school course, and the coach was helping him to remember his geography. So, when Albania came up, it was Albania, you are on the Adriatic, and your chief export is chrome. So if there was a tune, then you could remember it. So here's the minus V div tune to remember it. Minus V div B, minus V div B. You're the missing term in Maxwell. You belong on the right side of Faraday, and the truth is known at last. Everybody knows. So what is a scalar wave? Tesla called it that. It's a longitudinal wave in which one of the fields has a projection in the direction of travel. That makes the velocity difficult because it isn't going uniformly at some velocity. It's doing that. And it is a sphere as compared to an umbrella. So that's why there's no loss in this connection. Well, you could say, well, how can we have got this far and not know this? How could this be new? Well, it's not new. Near field effects are this. Antenna noise is this, says Mile. Permittivity of space or materials is sometimes called complex. Well, that doesn't make any sense. It's this thing popping out, right? You can't keep it in the box. And sometimes they speak of the complex speed of light, for goodness sake. So some detail on the Faraday cage. Eddy currents, as in eddy currents is why we have to laminate transformer cores, right? We can't let them be a mass of conducting iron, or we would dissipate everything that we're trying to get across the gap in the core. Near fields only transfer energy to very nearby receivers, and when they do, the result is felt as an extra power draw in the transmitter. So the transmitter hears the receiver. As an example of such an effect, power is transferred across space in a common transformer or a metal detector. And it's strictly short range. We say it's a sixth of a wavelength. This stupendous piece of work by Constantine Mile is really a physics without postulates. He derives everything from first principles he hates postulates and has worked until he didn't need them anymore. And it's a uniform physics that applies to all scales. Today we have astrophysics is very different, has no connection to nanophysics. So it's certainly worth reading. And he goes on to Poisson and Schrodinger equations as part of his derivation. Applications. We have power over Ethernet. This is like that in the sense that energy transfers and you can communicate too. We can beam power to a remote location like a hunting cabin in the woods. We can check vehicle tire pressure without having to have batteries in the rotating elements. Power and communications in a mine, for instance. Submarine communications underwater. And there are medical homeopathy benefits emerging in our climate. So all truth passes through three stages: ridicule, violent opposition, and then accepted as self-evident. Where are we here? If you start something 100 years ago and it's ignored, not even ridiculed, is it? You're one step ahead, you're a genius. 2 steps ahead, you're a crackpot. So here's John's bee. He flies we know not how. Now there are some theories, like from a Cornell physicist, Wang, but there isn't a uniform agreement on how bees fly. So this idea of bees creating vortices, that is what combats gravity. That's fascinating because that's very much in line with Miles' ideas and Tesla's. So insects depend on vortices to keep them aloft, especially when they are hovering, like a helicopter. Understanding of the vortex shedding and how these vortices behave when they separate from the moving surface that created them. And then this is astounding. Bees beat their wings at 200 cycles per second. Their thorax muscles do not expand and contract on each nerve fire, but rather vibrate like a plucked rubber band. The sound is actually the result of the bee vibrating its flight muscles. This can be achieved while the muscles are decoupled from the wings, a feature known to bees but not other insects. Decoupling. Maybe that sounds like Tesla's advice in his patent. You can't build it like a transformer with very tight coupling and low leakage flux. You've got to decouple. So maybe we're copying nature with tornadoes and bees. So the fan blows, we know not how, unless we know Tesla. Then we know how. Again, how could this be new? Well, by the way, the noise on antennas, what Miles says is that these vortexes, when they collapse, they're creating the induction that is the noise that couples every antenna. He's also suggesting that the near field around the antenna is what gives rise to the transverse wave outside of the near field region in every antenna. There's a thought.